Hello, all of you, and this is our third class of motion chapter in which we are going to discuss about speed and velocity. We all think that speed and velocity are the same, but they are not. We'll discuss about them as well as we'll solve some numericals on them as well as on distance and displacement, which we did in our previous class. So let's get started. So let's just try to understand that what is distance and what is speed and what is velocity. So basically, speed is distance per unit time. That means distance upon time. Okay, this is the formula of speed. Whereas velocity is displacement per unit time. That means the formula is S upon T. So that is a very big thing. That means it is the distance per unit time, displacement per unit time. Like in this much time, how much distance has been covered. In this much time, how much displacement has been covered. That is the velocity. And one thing is common, then that is their unit. The unit is meters per second. Now, how did we get this unit? Distance, we know the SI unit is meter. Time, we know the SI unit is seconds. So it becomes meter per second. So this is the unit of speed and velocity. I hope it is clear. Now, in many a times it happens that people get confused that how to convert, because sometimes we are given with kilometer per hour, sometimes we are given with meter per second. So how to convert kilometer per hour to meter per second and meter per second to kilometer per hour? See, we all know that 1 kilometer is equal to 1000 meter. 1 hour is equal to 3600 seconds. So if we just divide both of them, we get 5 by 18 meters per second. That means if we want to convert the kilometer per hour into meter per second, then we have to multiply that number with 5 by 18. Suppose I'm taking an example. If I want to convert 54 kilometer per hour into meters per second, then how will I convert? It is very easy. I will multiply 54 by 5 by 18 so that I can get the value in meters per second. 18 ones are, 18 threes are, it becomes 3 fives are 15 meters per second. This is your answer. Okay, so in this manner, we converted kilometer per hour and meters per second by multiplying by 5 by 18. And if you want to convert meters per second into kilometer per hour, then you will multiply by 18 by 5. Okay, like you can convert this. If you want to convert 15, then how do we do? It is very easy. You can just multiply 15 by 18 by 5. Yes. So 5 threes are 15. So 3 18s are 54 kilometer per hour. Again, we got the same measurement. So it remains the same. So I hope interconversion is clear. Now let's move to some numericals so that we can understand the concept in a better manner. Now let's move to our first question. An object covers 20 kilometer in 2 hours. Calculate speed in kilometer per hour and meter per second. Kilometer per hour, meter per second. First of all, you should know the formula of speed. What is speed? Speed is distance upon time. Just now I told you. Distance upon time. Distance is given to us 20 kilometer. Time is given to us 2 hours. So can't we write 20 by 2? That is equals to 10 meter per second. So our answer in 10 kilometer per hour. So answer in kilometer per hour is 10. How to convert into meter per second? Just now I have told you. If you want to convert into meter per second, you have to multiply this by 5 upon 18. Okay. So multiply 10 by 5 by 18. Sorry. 1 minute. We need to multiply it by 5 by 18. 2 5s are 10, 2 9s are 18. So it becomes, I think, 25 by 9. How much we'll get? 25 by 9, that is, and 2s are 18 point, then So it becomes 2.7 meter per second. This is your answer, and this is your speed in meter per second. 10 kilometer per hour is in kilometer per hour. 2.7 meter per second is in meter per second. So speed is the same. If you want multiplied by 18.5, you'll again get the same answer. So in this manner, we can convert. Now let's move to the next numerical. This is our second numerical. A train covers 54 kilometer in 30 minutes. So first convert the units into meter and second. So 54 kilometer is going to be 54,000 meter. Multiply by 100. So it becomes 54,000 meter. And 30 minutes, if you multiply 30 into 60, you're going to get 1800 seconds. Okay, 1800 seconds. Now we know speed is equals to distance upon time. So this will be equals to 54,000 upon 1800, because we know speed is distance upon time and we have converted into meters and seconds. You can see the units. So if we just multiply 0 to 0 gone, 0 to 0 gone, 540 upon 18. So 18 threes are is 54 and 1 0. So it becomes 30 meter per second. This is our final answer. So answer is 30 meter per second. If you want to write in kilometer per hour also, you can write by multiplying into 5 by 18. So in this manner, we have solved this numerical. Yes, our next question is that a car covers 12 kilometer in 80 seconds. Calculate the speed. Now we know that the distance is 12 kilometer. That is in 2000 you will do, so 12,000 meter. Time is given to us, that is 80 seconds. It will remain seconds only. Yes, seconds is the SI unit of time. Now divide both of them, because speed is equals to distance upon time. So 12,000 upon 80. 0 to 0 gone, 1200 upon 8. So it becomes 150 meters per second. So in this manner, we have solved this question easily. Very, very easy question. Okay, I hope you are understanding the questions because they are the basic ones. This is a numerical based on distance and displacement. What is it saying? A body thrown vertically upward. A body has been thrown vertically upward, reaches a maximum height h. So this is the maximum height. It then returns to the ground. Again, it returns to the ground. Calculate distance and displacement. Now, in this case, we can see that first we are throwing, so h. Again, it is coming back. That means one more h, because it is the same. That means distance is 2h. Yes or no? And we can say that this was the initial position. Achha, let me change the color. This was the initial position. It was thrown upward. Again, it returned to the same position. That means initial and final position is the same. That means displacement is 0. In such cases, displacement is always 0, because the initial and the final position is the same. Same happens with a circular motion. Here, distance and displacement are the same, because the final and initial position, displacement is 0, because final and initial position are the same in these cases. So this is the last question for today, and the question is that a body travels a distance of 3 meter from A to B. Let's try to draw the figure. So from A to B, a body is traveling a distance of 3 meter. Okay. And a distance of 4 meter at right angle to AB. That means, wait, this is A, this is B. And then what happens that it is at right angle to AB. 4 meter, a distance of 4 meter. So let's say, and a distance of 4 meter here. Now we have to calculate distance and displacement. So distance is going to be 3 plus 4, that is 7 meter total path. Then what is going to be the displacement? This is the initial position, this is the final position. So the shortest path is going to be this. And as it is a right angle, we are going to use Pythagoras theorem. Let's say this is C. So using Pythagoras theorem, you all can calculate this is a triplet. So S is 5 meter. You can just say AC square is equals to AB square plus BC square. That is 9 plus 16, which is 25. So AC is going to be root of 25, that is 5 meter. So in this manner, we have solved all the interesting questions about distance, displacement, speed, and velocity. We are going to talk about acceleration in the next class. So bye-bye.